Okay. Now, when I tested all the tubes in the radio, the eye tube did not test well. And this is the eye tube right here. You can see the little bit of target in the middle. And so I had to say to myself, okay, let's go to eBay or someplace and pick up a 6U5. Well, the prices of a 6U5 are out of control. They're through the roof. So I saw, a Soviet 6E5S is pretty close to a 6U5. Maybe if I built an adapter base, I could make the two. So here we go. Here's what you see. Pin 1 is the filament. Pin 2 is the filament. So I've got to go from pin 1 to pin 2. Pin 3 is the plate. Or excuse me, pin 2 is the plate. Pin 3 is the plate. Pin 3 is the grid. Pin 5 is the grid. Pin 4 is the target. Pin 6 is the target. Pin 6 is the filament, and pin 7 is the filament. So we've got to wrap this all around and build an adapter to do this thing. So what I did was I went through 2 steps, or 3 steps as you can see. I put the bases side by side. I made a wiring arrangement where it shows where filament goes to filament, 1 goes to 2, and so forth. The only funny one is this one here where they cross over. Pin 5 goes to pin 8, and pin 6 goes to pin 7. So that's kind of funny. So I said, okay, I've got that down. Now let's make something I could actually use and build from. So I put it down here as a focusing from the 6U5 to the 6E5. 1 to 2, 2 to 3, 3 to 5, 4 to 6, 5 to 8, 6 to 7. So that's how I need to build my conversion socket. Now, I'm to understand the 6E5C is a little bit more sensitive of a tube to the signal strength, and the 6U5 isn't quite as sensitive. So it might be interesting to see what we get. We'll get a little more sensitive tube matched with a 6U5 tube. Okay, so what did I do? I took the old eye tube and I busted the glass all around it so that I could have just a base socket to form the socket part of the adapter. This takes you got to be careful doing this. This takes great care because you're breaking glass, and the glass is sharper than the devil. And the first thing is it's under vacuum, so it's going to want to wander very quickly. But nevertheless, I soldered it up. So what we're doing here now is we got this piece of wire, and we're going to stick it into the socket and solder it to the top of the pin. Then we trim it to a length that I can attach this connector. Now you may wonder why I have extra leads, because what I'm going to do is tuck this right in. By coincidence, the base of the 6E5 socket is exactly the inside diameter of the 6U5, so they can snap right into place, and it's pretty cool. Okay, let's get to showing you how I soldered the pieces. I saved you from the agony of watching every one, so I did all of them but one. My 2 white wires are pins 6 and 8, with 6 having a mark on it so that I can see which one is which. 6 or 1 and 6. I do that all the time, by the way, so this ought to be interesting to see how I wire this darn thing up. I transpose things. So let's get started. The first thing we do is we spin the lead into a very, very tight twist. Then we dip it in the solder paste just up to the insulation so that we have flux on the insulation, and then we solder the darn thing together. Got a little bit of solder on the tip. Just a dab will do it. And we solder it. Now because I put solder flux on there, it solders very quickly and sucks into all the cracks nooks and crannies. So, okay, we got this pin soldered. So now what do? We take our tube socket, insert the wire into the last hole. That's kind of an interesting point, too, as we're getting here. The holes are very small. You have to make sure the wire can fit through the hole. And you also have to clean it completely of the old wire that was in there and the solder. So the very first thing you do is clean these pins out quite thoroughly. Now let's stick this in and see what happens. There we go. I don't know if you can see it so well on the camera, but the wire is just protruded through the tip of the pin. I'm going to pull that back just a skosh so that I can get the silicone insulation away from the very edge of the pin, and then we're going to solder it. Now this takes a little bit more finesse, because what we want to do, and in fact, I'm going to put a dab of flux on this part here, on the pin itself, because I want the solder to take to the pin very quickly. Yeah, hand in the way of soldering. How can we do this? The hand's not in the way. I know. There we go. That's a little better. Now we put a dab of solder on the tip, and we begin to heat the pin and the wire simultaneously. If you do that, you'll get it'll suck a little solder in, and you'll get a very nice bead at the top. A bead that clearly shows the solder has connected itself to the pin. Now we give it a minute or two to cool, because that thing's a hot little devil. And then we just snip off the very excess lead. There. Now we have our tube base. Oop! I forgot to trim this end off. So we line it up with one of the other wires. This is very hard to show on the tube. I'll get my fat hand in the way. Let's see if I can do it this way. Anyways, I trim this wire, this little extra wire, to the pre-trimmed wires that I've already done from before. So we will trim a little bigger. That's good enough. This is only an approximation, so you get down to it when the soldering actually begins. Now, I'm going to take a little break and solder up all these wires. I'm going to use the same process, strip it off 1/4 inch, twist the wire, flux it, and then just touch it with a tab of solder, and the smallest amount of solder is all that's necessary to tin these wires. And tinning wires, particularly stranded wires, are very, very important, because all of a sudden, if you use untinned wires, and there's a little bit of oxidation on them, when you go to solder something with it, it just doesn't take. It turns into a pain in the neck. So each one of these wires are going to be twisted and tinned. And when we get back, we'll start building it into this pin socket. And I'll see if I can figure a way to get my hands out of the picture so you can actually see what's going on. All right, I'm back. After I've soldered all these little wires that went into the pins, except for this last one. I thought I would share it for you. This is number 6, which goes to number 7, this pin right there. I know it's hard to see, I apologize, but I'm going to put it on and solder it. Ouch. If you know, notice I made a little hook in it, little hook in the wire. I should have some piece of paper or something to contrast it. Let's see. If you notice, I made a little hook in the wire to hook around the eye of the tube socket. And then when I put it through the eye, I'll crush it together, and that'll make a good solid mechanical connection. And then we will test it out. How are we going to test it? Well, we're going to test it by continuity first. Okay, I know you can't see it. I'm sorry, it's a little bit of a thing, but I'll apply some solder to it. Give the solder a minute to settle. Looks like a good joint. Now I'm going to do a very spooky thing. I'm going to crush these wires. So to summarize, I connected a wire to each pin through the soldered a wire to each pin, and then I connected all the wires according to this diagram here up to the pins, or at least I hope it's that way. I'm just going to shove this in and see if it does anything. Hey, look at that. It's tucked in so very nice. Maybe I'll put a wrap of electrical tape around it. Anyways, let's ohm it out. This is pin number 1. And the question I have is, where is pin 1 goes to 2? So this is 1, 2. Oh, wrong setting on the meter, wouldn't you know it? Sorry about that. Let's see, this is 1, doesn't go anywhere. 2 is where it goes to. And I counted backwards on the wrong side of the socket. Boy, I'm just a real klutz here, aren't I? 1, 2. Okay, so this pin 1 goes to the white pin 2, the 6E2. And just for the sake of it, I'll check on either side of the pin to make sure nothing's shorted together. Okay, this is pin 2. Pin 2 goes to 3. 1, 2, 3. That's good. Nothing, nothing. 4. 4 goes to... Oh, did I miss one? I think I missed 3. I'm on 3. Okay, so this 3 goes to 5. 1, 2, 3, 4, 5. And we'll check on either side. That's good. Now we'll go to 6. And 6 is the first one that flips up. So 6 is going to go to 7. 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6. 6 goes to 7, and it does. And finally, we go back to the 6U5, pin 5, and pin 5 goes to pin 8. And it does. And we'll check one on either side. I don't think I checked one on either side on this one. Well, that's the connection anyways. So we connected it all together. And number 5 went to 8. And 8 is right here. That's good. Anyways, to that crazy business there, we've connected it all together and we've got something. So now what this thing is supposed to do is plug into this socket here. You got to make sure you line it up properly. There's a pin 1 dot. I don't know if you can see it or not, just above my fingertip. There's a pin 1 dot, which has to go to pin 1 on this thing. This is pin 1 right here. This is pin 1. This is the pin 1 dot. We'll plug that in nice and snugly. And we're going to double check to make sure. We check, and double check. 1 goes to 2. 1, 2. So that's aligned up properly. So now you might be tempted to plug the tube in right away and see if it works. Well, we're not. We're going to use our DVM and check the voltages. Make sure that the voltages on the socket are what I would expect them to be based on the schematic. Okay, now we're prepared to begin the third and final set of pre-tests before we insert the I-tube, the actual tube, into the socket. And this is all for protection of the I-tube and the rest of the radio. So we'll check the voltages across this new tube replacement and make sure each voltage is what we probably expect to see. Number 1, gosh only knows, it's a pin. It's a unused pin. Now, oftentimes people like to use these pins as tag points underneath on the tube socket to go to other parts without infecting the tube. However, be very careful, because sometimes, even though it says it's not connected or X, it may very well be connected to some other component within the tube. Okay, pin 2 is the heater, and that's an AC voltage, so we don't see any DC. We turn it to AC, and we see our heater voltage, 7.2 volts. I'll switch it back to AC. And after the heater, we go to the plate. That's going to be a very high voltage. Oh, by the way, I'm holding this kind of carefully because these pins in the back are, in fact, high voltage. It would give me quite a snap. So we're being very aware of that. So now we go to pin 4. And that's gosh only knows what, mostly nothing. It's an unused pin, maybe. Then we go to the grid, which is the AVC voltage, which should be a negative voltage. And because I've got a station tuned in, we see negative 5 point whatever, 4 point whatever. This bouncing up and down is the AVC action that's keeping the volume constant on our radio, even though the signal is changing. After the grid, there's another pin 6 is another plate, the target, and that would be a high voltage. After that is number 7, which is a heater, which is 0 volts, and the reason why this particular case is 0 volts, well, let's do it on the meter anyways. Let's check the meter anyways. We stick the meter in, boom. We stick the meter in, and it's 0 volts. Why? Because that pin 7 goes to chassis. All the heaters apparently in this radio have one side tied to chassis. So now put it back on DC to measure the cathode, the last pin, pin 8. And we see that it is 0 volts, which is expected because on the radio schematic, pin 8 is in fact the cathode. So all the voltages in the socket appear to be what I expect. Now it's time to plug the thing in. Should I turn it off first? Yeah, that would probably make a lot of sense. We flip it around and find the key locator pin. Now, even though I've turned it off, I could still get quite the shock off this thing if I didn't wait long enough for the bulk capacitors that regulate the DC to fully discharge. Okay, now we turn on the big moment. Well, nothing bad happened immediately. Okay, so there we are. The green phosphor has appeared on the tube. Now there's a lot of light around here, so it doesn't show very well, but the tube is there. And if you noticed, it's a completely closed phosphor. It just starts at one end and it goes continually to the other. That means the station is tuned in and tuned in fairly strongly. Let's try with the volume. Now, it's there, but I'm in the basement. I've got a really crappy long wave antenna, so there's a lot of static noise. And a lot of that static noise is due to all electronic devices in here as well. Something to keep in mind, I guess. Anyways, let's keep an eye on this shadow as I detune the station. See, I'm coming out of tune. It opens up. The shadow is opened up. Come back into tune. It's closed. Let's see if we can find some more stations. Here's one. And that's the best you can tune that particular station. There's another one. You can just watch the tube. When you go by a station, it'll flip closed. And I guess that's it for stations.
Yeah, pressure in general, I loved it in my sport. Like, I love pressure.
And there you are, fully closed, and a very well-tuned station. I'll turn this down. So there we are. We have actually taken an iTube, taken a Russian 6E5C tube, and converted it to work in a 5U4 socket. Now that's pretty cool. So if you run into a problem like that, you can always fool around with a socket base to make it work with a less expensive iTube. Well, generally you always can. Anyways, I guess that's all for now, Tube Timers. I thank you very much for your participation, and if you liked it, give it a thumbs up at the bottom. This is the first video after a long time, so I'm a little bit woogity here, particularly in the beginning, but it'll get better. The next session is the final session, and it is going to be tuning the station, or tuning the radio, going through and tuning the IF coils and then tuning the antenna coils to make sure that we're getting the most we can out of our antenna. That's all for now, Tube Timers. Take care and be safe.